Hello and welcome to another PAVE weekly virtual panel. My name is Ed Niedermeyer. I'm the communications director here at Partners for Automated Vehicle Education. Thank you so much for joining us today as we look at our upcoming annual PAVE gift guide preview. We do put out a gift guide every year. This year's will come out tomorrow. In fact, if you're watching this recorded, it's probably already out. Go to pavecampaign.org to find that. And otherwise, look for it on social media. We try and highlight a really wide range of products, and today we'll be speaking with folks from both the world of DIY and hobby robotics, which we always include in our gift guide, and as well as the author of a really fascinating book about automation and society in the second half. But first, let's go ahead and introduce our first two guests. Joining us today are Dustin Franklin. He is a principal technical marketing engineer from NVIDIA. Dustin, welcome.
Hello, thanks for having us, everyone.
And Jacobo Tani, he's the co-founder and CEO of Duckietown, Inc. And it looks like we have, hi Jacobo, it looks like we have our third guest as well. Kate, if you could go ahead and turn off your camera for just a moment, I'll have you on in just a few minutes. Thanks. And so let's start with you, Dustin. You're with NVIDIA. NVIDIA makes a wide range of sort of DIY robotics and AI platforms. You know, how did NVIDIA get into that business, and what were sort of the goals of doing that?
Great question. Okay, so as many of you probably know, NVIDIA we're really known for the graphics cards and the GPUs and data center and PCs and laptops and things like that. And so all of this really began back in around 2005 when NVIDIA had the foresight to come out with this architecture called CUDA, which is almost like C++ code for generally programming GPUs with a parallel computing model. And from there, people started doing all types of things in computer vision. And when I got out of school in 2009, my first job was taking normal PCI Express graphics cards and doing computer vision based navigation and autonomy for some of the first autonomous vehicles. These were for the Army autonomous Humvees with Carnegie Mellon and things like that. And then over time, there was more and more interest in actually doing real embedded applications and devices with these, and NVIDIA had this system on chip called Tegra, which was used in smartphones for a time and also handheld tablets and devices like the Shield. And so, we thought, hey, why don't we just scale this down and turn it into a small developer kit that could be used for whatever people want to do with it, small devices or robots, things like that. So it all kind of stemmed from that. And the first one was called Jetson Tk1. That was in 2015, I think. And, every year or two, we come out with new Jetson that has 10 times the compute power to it. And it's really, they take the same silicon design and architecture family. The latest one is Ampere or Volta or Tesla Turing family of GPU, and they just take that and scale it down and couple it with some ARM cores and camera interfaces and video encoders and decoders and all of that stuff. But the cool thing is it all runs the same code that you would on your normal PC. So these days, that's things like PyTorch and TensorFlow and OpenCV, Linux, things like that. And predominantly it's programmed with Python and C++. So really it stemmed from the larger architectures that NVIDIA makes, and we just scale that down to be very small and power efficient. And it's the least expensive, smallest products that NVIDIA makes today.
Cool. Yeah, it's fascinating. I think sometimes people look at these things and think, well, it's a toy or whatever, and the fact that it has such deep roots in really the core of the company's business is really fascinating.
Yeah, we are very developer friendly, but at the same time, like many of the world's most advanced robots are powered by these Jetsons today. Like even like last week, I was in my grocery store here in Pittsburgh, that's where I work, and saw a robot driving around that has a Jetson in it, and it was doing like it was scanning the shelves for like inventory levels and stuff. So that was like a really cool kind of like circle of life moment where like, wow, the product I work on is now deployed into the real world, and I like ran into it in my everyday life.
Yeah. Well, so one of the really cool things that kind of shows, how people can kind of get towards that sort of professional grade work down the line, if that's a goal for them personally, is of course Duckietown, which has partnered with NVIDIA or uses NVIDIA's hardware. Jacobo Tani, Duckietown's your thing. Sort of, if you could just explain what it is, where it came from, maybe even who it's for, and what it seeks to accomplish.
Absolutely. I would start by saying that Duckietown is more than just my thing. It was the result of the work of many people across the years. We started from a different angle. Back in late 2016, we were teaching a robotics class for the master's students of MIT. And we just wanted to teach it in a better way instead of the usual bunch of equations at the blackboard and the final test. And so we challenged the students, brave souls, and ourselves to basically build from scratch a model, miniature smart city with a fleet of self-driving cars going around so that we could both do the research that our lab used to do with smart mobility and things like this, and provided this step-by-step guide to people that wanted to learn these fascinating topics in a very practical and accessible way without sacrificing, though, the, let's say, scientific and technical rigor behind it. And so that's how Duckietown was born, as, let's say, an experiment, an education experiment. We've gone a long way since then, and now Duckietown is let's say, a robotics and AI ecosystem. So it has many components. Of course, the most physical are the Duckiebots, the small self-driving cars that navigate Duckietowns, which are these modular urban environments that can be upgraded to literally become from little small loops to fancy smart cities of arbitrary topology. And Duckietown today is used by over 130 universities around the world to teach robotics and AI, either through our content or through what professors want to add. Duckietown is open for developers. And it's used by over 90 companies and research labs to either do in-house training, upscaling, reskilling, or research, and thousands of, let's say, independent learners around the world. One of the, let's say, other most visible parts of the platform is this massive open online course that we launched at the beginning of this year. It's called the Self-Driving Cars with Duckietown, and it's currently hosted on the edX platform. And that is more oriented towards, let's say, people with lower initial experience in the themes of robotics and AI, and they can follow along while having hardware in their living rooms or bedrooms or wherever they are taking the course, and actually building and experiencing the pains and the joys of real world robotics as they go.
Yeah, absolutely. And so, as you mentioned, I mean, you're talking about university level, you're talking about even in the professional environment is where Duckietown's being used. Dustin, this is also a really part of a really big world of DIY and sort of hobby robotics platforms. Can you sort of walk us through maybe some of the other options from NVIDIA that kind of maybe more oriented towards more entry level or kind of just help people understand sort of what the range of different sort of points of entry and to this hobby?
Sure. Yeah. So I guess just to be clear, the only product in the Jetson world, which is like our DIY embedded platform used for robotics and view analytics and things like that, are like the developer kits and the modules. And then we have an extensive array of partners such as Jacopo at Duckietown, other universities and such that have built courses around this material. And I mean, we have kits out there like the JetBot and Jet Racer, and there's lots of other robotic kits that can be used as well. in addition to actual like production grade ecosystem partners that make the real like systems, like outdoor all-weather IP rated systems or cameras that go along with it. So we have a whole range of things, just from like very basic entry level to all the way to like, I'm going into production with this device and I need someone to help me design like an actual carrier board for it and make the real embedded system for it. But just last week, we actually launched a new teaching kit in collaboration with Oxford and University of Maryland that kind of wraps up a lot of the material that we've been working on. Everything from basics like, I've never done deep learning before, how do I do that? How do I train my own model? All the way to like training autonomous robots to do navigation and collision avoidance and things like that. In addition to all of the great course material that's already out there, like what Jacopo's put together at Duckietown, and there's lots of other university things out there. So there's really like a wealth of material, both for teachers and for students and hobbyists alike.
Absolutely. And Jacopo, I'd like to get your perspective on that as well. I mean, if someone, really wants to do Duckietown someday, but their skills aren't there yet, I would say like both maybe the ideas for products or skills to focus on developing, like to start with, and then also maybe like where can you find community to help support your sort of growing into this hobby?
So depending on one's background, getting into robotics can be maybe scary a little bit at first, because there's really a wealth of options out there. And robotics is I would say fascinating. Other people would say weird, because it's sort of like the queen of engineering. It's where everything comes together. It's really multidisciplinary. So really no single individual has, let's say, all the skill sets required to master every aspect of Duckietown. Like, it's when atoms and bits come together, to quote Dr. Adrian, one of the co-founders of Duckietown. The software needs to be deployed on the hardware. The hardware tends not to want to agree with the software. And then there's all the development environments and what language are you going to use and what solution, and it might be confusing. So we put an effort when we designed the Duckietown from start to try and get to the simplest possible architecture in all directions, from the hardware to the software, so that people could get started without getting confused by the many options, but still being able to really tackle the open challenges and the problems, and actually be able to do research as well. Duckietown has been used to publish many peer-reviewed papers and do lots of fun work. So to answer your question on how to get started, well, there's many options. One needs to get started, because it's only through repeated failure that the success is achieved, right? So the important is trying to, my personal opinion is trying to deal directly with the actual real world problem. You cannot avoid the real world when you do robotics, unless you want to do theoretical robotics. Duckietown offers a choice of instruments. Of course, there's plenty more out there, and Duckietown offers a community as well. We have a live community hosted on Slack, as well as other platforms, and learners from high school to professors with white beards come together to discuss various aspects of this journey.
Yeah, absolutely. Well, this is great. Also, in our gift guide, we really tried to include some, really kind of much more basic kits that really just introduce, much younger kids to sort of just the very, very basics of this stuff. Hopefully to help them sort of maybe start to find some of their specific interests, as you mentioned, that they can pursue into more advanced DIY robotics, which of course NVIDIA and Duckietown are helping make possible. Thank you both so much for coming here today, spending the time to share your knowledge about this really fascinating field. Dustin Franklin from NVIDIA, Jacopo Tani from Duckietown. Thank you both. And if I could ask our third guest to turn on her camera and
thank you for having us. Bye.
Thanks, Ed.
Hi, Kate.
Hey. Sorry for popping in too soon. I was just so excited to be here.
No, we're very excited to have you as well. So our second guest here, it comes from the book section of our annual AV Fans Gift Guide, where we really try and highlight sort of a broad variety of books. You don't have to just be, and I say this with someone from a non-technical background, you don't have to come from a technical background to find AVs fascinating. I think, and this book is a really great example of how to really get into automation and some of the issues it raises from a not necessarily just purely looking at the technology itself. So Kate Darling is from MIT Media Lab. She's the author of The New Breed. Kate, can you just briefly tell us about the book, sort of who's it for, and what were you trying to sort of impart to that audience?
Yeah, sure. So like you mentioned, it's not just for people with a technical background or academics, it's really for anyone who is interested in robots or automated technologies, anyone who's interested in animals even. A lot of people from the animal community actually enjoy the book, or anyone who's just interested in our technological future. And what I was trying to impart with the book, so the reason I wrote it is I love robots and I talk to everybody about robots all the time and have been doing so for the past decade. And I've realized that in all of my conversations with, whether it's the roboticists, whether it's, people at a garden party, whether it's someone on an airplane, we're constantly, when we talk about robots, making this comparison in our minds subconsciously. We subconsciously compare artificial intelligence to human intelligence and robots to people. So whether we're talking about robots replacing jobs one-to-one, whether we're talking about what intelligence is, we constantly fall into this comparison. And what I want to do with the book is get us away from this, because I think that it's very limiting. First of all, artificial intelligence is not like human intelligence. It has a very different skill set. And second of all, I think it changes some of these conversations in really impactful ways, and it opens people's minds to new possibilities, because why focus on recreating skill sets that we already have when we can create something that is different and supplemental? So that's really what the book tries to impart.
Yeah, and so you just explained really well, I think, why I sort of look at animals, but if you could kind of tease into, so what are some of the specific things that you found in this, right? Because you're looking at the history of humans' relationships with animals and trying to pull out lessons that might apply to our automated future. What are some of the things that you found while doing that?
Yeah, so I've always found animals to be a better analogy for thinking through AI and robotics. It's not a perfect analogy, but it is one that makes a ton of sense in a lot of contexts, and it doesn't come to mind as easily as this human comparison, but it also acknowledges that people treat robots differently than other devices, which is a lot of what my work in human-robot interaction is about. But essentially, animals, we've domesticated animals and used them for work, for weaponry, for companionship. And we've worked with animals not because they do what we do, but because their skill sets are, again, supplemental to ours. And there's so many really fun examples of how we've used animals. We've used oxen to plow our fields. We've, the US and Soviet navies both invested in marine mammal training programs. And there are a lot of ways that we've used animals in the past, and we're currently trying to use automated technologies to do the exact same function. So in that sense, the analogy makes a lot of sense. But it's also not like the argument of the book that robots and animals are the same. There are obviously huge differences, but just thinking about this different analogy opens our minds to new possibilities for how we can use automated technologies. So that's why I chose animals. Yeah,
absolutely. And I mean, you talking about some of the different ways in which we use animals is it really helps, make that connection. But also, I mean, our history of animals is also full of like weird sort of problems and questions, right? Like if you own an animal, but it runs rampant, and destroys someone else's property or something, are you responsible? Is the animal responsible? I mean, that's something that kind of has a lot of significance to trying to sort out really important questions for our future, right?
Oh, totally. And, part of what I really want people to understand is that we don't need to reinvent the wheel. We often have this idea that, AI and robotics are, so they raise completely new issues in society that we've never dealt with previously, whether that's, replacing our companions, or whether that's, like you said, responsibility for harm. I see a lot of legal scholarship going in the direction of, well, this is unprecedented. We've never had to deal with the question of unanticipated autonomous behavior before, except we have had to deal with it in a lot of different ways with animals ever since the first laws that we created that are known to humankind, that were etched on clay tablets. They were about what happens if you have an ox and it wanders off into the street and gores somebody, like you said. So there are a lot of different ways that we've dealt with that throughout history. We've put animals on trial for the crimes they've committed. I have a lot of very fun history in the book. But yeah, we don't need to reinvent the wheel. And I think that there's so much that we can draw from this rich history that we have using animals.
Absolutely. One of the other books that's on our list this year is Adrian Mayer's Gods and Robots, which is about sort of ancient Greek mythology and them sort of wrangling with some of these questions as well. So I think that insight that this is stuff that we as humans thought about even before, you know, the technology was close to existing, it opens up like a whole place to go where you're not just speculating, right? Where you're digging into actual thought and debate and discussion that people have had before, right?
Exactly. I love her book too.
Yeah. Was there anything that you came across in this study that you did for the book that kind of particularly applies to autonomous vehicles? Obviously, robotics is a huge, diverse field, and AVs are kind of a little bit more of a specific piece of that. And I'm just wondering if there's anything specific you could share.
Yeah, I think, well, the main lesson of the book that we need to be thinking outside of the box in a lot of these industries definitely applies here as well. And, you know, there are some examples, like, for example, we used to use horses to, you know, get around. And then we invented the steam engine, and the steam engine wasn't an iron horse. It was something different, right? It changed the nature of how we can travel around. And so I think that the main lesson that I keep pushing in the book is we need to be thinking outside of just like this replacement idea that we have, and really be thinking creatively about how these systems can actually change how we do things and change the architecture of things and change, you know, how we live, rather than just trying to automate something we already have.
Yeah, absolutely. It's so aligned with one of our big goals here at PAVE is to help people understand this is not just about cars that drive themselves, autonomous vehicles. This is really diverse range of vehicles that can do all kinds of different things and look all kinds of different ways. Just like, you know, what does a robot look like? It looks like whatever you need it to look like to do that task. And AVs are definitely the same way. So that's a great lesson. Based on your research, and I don't want to put you on the spot on this, but you delved into some, lots of ancient wisdom, not to use a cliche about that will help us sort of see into the future. Does it feel like, we as a society are kind of set up to sort of deal with the challenges and the opportunities, I guess, of automation? How do you feel? Do you feel optimistic about our ability to handle all this? Because it's a lot of change, even though a lot of it is stuff that we've been thinking and talking about for a long time.
Yeah, I raise concerns in the book, but ultimately it is a story of optimism and a path forward, because I think the challenge that we have with automation, so with AI and robotics, is that unlike other technologies like, I don't know, cryptocurrency, people can kind of picture in their minds what AI and robots are, but that picture is so influenced by science fiction and pop culture that it leads to a lot of assumptions that I think can lead us astray in some cases. And I love sci-fi, but I have a love-hate relationship, because I feel like there are some tropes that just get repeated over and over again, and they lead to this technological determinism, for example, that robots can, should, and will replace people. That is very persistent. So I think that as long as we can understand that we are influenced by sci-fi and pop culture, and as long as we can recognize that we actually have choices, and we don't just have to succumb to this determinism that we have set out for ourselves, I think that there's a lot of potential for this technology to be not just helpful, but super fun and interesting, and make life better for people. But it's on all of us to make the right choices, whether that's in technological development, whether that's in integrating the technologies, or even just politically the social and economic systems that govern how the technology gets used, I think it's on all of us to make the right decisions.
Absolutely. And that's really, I mean, one of the reasons why it is so important for people from non-technical backgrounds and a really a wide variety of disciplines to kind of engage with this topic, right? Is because you need sort of those, you know, an engineer who's, you know, or someone who's brilliant at, you know, computer vision or something is not necessarily going to be the right person to be thinking through some of the, well, certainly like the legal consequences, but the social consequences as well, right? And it seems like this book is a really great way for people from those backgrounds to kind of start to engage with the topic a little bit more.
I hope so. And, you know, like I said, I hope that everyone reads it, right? I think it's great for engineers, but I think anyone can benefit from reading this book or at least be entertained by some of the fun stories in it.
Absolutely. And I wanted to ask you as well, I mean, because the whole idea of looking into our history with animals is one of those things that like, it never would have occurred to me, but as soon as I saw it, I think even before the book came out, I saw on Twitter, I was like, oh my God, it's perfect. It's such a great idea. In part because, as you mentioned earlier, like the default thing for humans is to anthropomorphize automation of all kinds, which can be really problematic sometimes. Was there anything that you've discovered about why it is that we sort of default so quickly to trying to think about robots as humans rather than maybe animals?
Yeah, so this is totally my jam, this question of why do we treat robots so differently? Why do we anthropomorphize them? Why do we treat them like they're alive, even though we know that they're not? Because you see this consistently in a lot of the HRI research, but there's also so many stories, right, of people, you know, 80% of Roombas have names. You know, nobody names their handheld Dyson, or maybe some people do, but not 80%, right? So why do we do this? Well, we're very social creatures and we tend to anthropomorphize anything. It's one of the first things that like a baby learns to see is faces, right? We see ourselves in other things constantly, and we project emotions onto non-humans, like onto our pets, onto animals. We love to project feelings onto animals that, you know, may or may not actually be there and often actually aren't. So there's that aspect. And then with robots, with physical robots in particular, there's the physical movement that our brains respond to. There are studies showing that we're, you know, kind of biologically hardwired to scan our environments and separate things into objects and agents, which makes sense because we had to watch out for the agents previously. But now we have these new objects that move like agents, and it really tricks our brains. So people will project intent and all sorts of things onto this movement. And so it's not even just sci-fi and pop culture. It's not even just the novelty of the technology. We're actually biologically hardwired to treat these machines like something in between something that's alive and not alive. So we don't treat them like our blenders, for example. And that lends itself to some, you know, you mentioned some problems. I think there are also some opportunities. If you look at how we've used animals for companionship and therapy in the past, I think there are a lot of opportunities for robots to actually assist, as long as we are aware and consciously leaning into some of the benefits of this tendency. I think that there's a lot that we can do. And then, of course, there are some concerns that we need to address as well. But that is all, you know, in the book. I think that ultimately, while, you know, there are a lot of concerns with like privacy and data security and algorithmic bias and a lot of things that we need to pay very close attention to, I think that the nice thing that I see in this future is that we can determine some of it, right? It's not just predetermined for us, like I said.
Yeah, absolutely. And certainly I think in you know, our work in AV education, it is sometimes helpful to sort of have people think about how they approach something that they do kind of subconsciously, like driving, in order to sort of explain and understand sort of how the different pieces of the stack work. But then ultimately too, as their understanding expands, what really jumps out is this is really different in a lot of ways too. There are certain structural similarities to how the tasks are done, but fundamentally a human brain and a computer are just very, very different things that are going to operate differently. I'd love to keep on chatting with you. It's such a fascinating topic and the kind of thing I can nerd out on for hours, but unfortunately our time is up. Kate Darling, MIT Media Lab, and the author of The New Breed, thank you so much for taking the time to be with us here today.
Thanks so much for having me.
Thanks. And you can find Kate Darling's book, The New Breed, on the PAVE's annual gift guide, along with a number of other really great books, as well as a section on hobby robotics. We have art. We have, you know, funny little things to put on your desk. It's a whole range of things that comes out tomorrow. You can find it at pavecampaign.org. And with that, I'd like to thank you all for taking the time to be with us here today and to prioritize AV education in your life. We really appreciate you, and we will see you here again on another PAVE Weekly Virtual Panel.